Record. Share. Oh, I have to stop my music there. Go. All right, then let's take some notes. Today is the 13th. I have an advantage over you for these notes because I have little pieces of digital graph paper that I can use. But so honestly, you're just going to have to do your best to just sketch. And as always, the notes that you take on day one are sometimes just a rough draft. The notes then that you create for a quiz, say like next week or something, then that's when we really get down to it and make our work of art notes. And so for today, I'm gonna introduce you to the concepts. And then for this lesson, I tried something a little new. I made myself a Delta Math assignment that I could use as examples to click through. Because as always, when I teach you something and then we go into Delta, it might look a little different when you get in there. So I thought I would just teach most of the lesson from the perspective of this is what your problems will all look like. So shouldn't take too long. I just decided to call today lines and their equations because it is again time now that we all understand slope. It's time to get in there and look at how the equation of a line and the line itself are related. So there are two ways you're going to see equations written today. The first one that I want to talk about specifically for a few minutes is y equals mx plus b. And we have kind of flirted with this topic a little bit. But as I mentioned, when that was happening, we didn't give it a full go. I had made reference to we're going to go into this full bore in this today. So if I give you an equation that's written in this, by the way, is called slope-intercept form. And the reason we call it slope-intercept form is because it quite literally gives us the slope and the y-intercept of the equation, which, as you'll see, are all the things in the world that you could possibly need. If someone were to give you a point on a line and then give you the slope, you're done. Like that's all you need. You give me 1 point to start at, and then you give me like a down 3, right 4, boom, I'm done. Like I got 2 points, I'm gonna make me a line. So that's where slope intercept is so powerful. It's where it really shines, is it makes it, graphing is like one of the easiest things in the world. So here's an example for you. Let's say we had like y equals negative 2/3 of x plus 4. If you've never done this before, prepare to be blown away by the simplicity. If you have done this, you already understand, I think, the simplicity. So the number at the back, the one that's not attached to x, is called the y-intercept. And so when we have these discussions as a class and I say, hey, where should we start the graph? Do not say positive 4. Say up 4. 1, 2, 3, 4. And the reason I get uptight when people say positive 4 is because sometimes people think that that means that I can pick either 4 that I want. That first number that we deal with is very specifically an up or a down amount. Okay, it's on the y-axis. So up 4 is where we start our graph. And now the other number, the one that's attached to x, that's our rate. That's our rate of change, our slope. And so having practiced slope now for a couple of days, could you use words and describe to me what a slope of negative 2/3 looks like, Brendan?
Down.
Yeah, and be careful with the word over. Listen, I'm like one of 6 people in America that seems to care about this, but my only issue with the word over is that it can be misinterpreted. So I'm not going to yell at you too much, but when you hear me talk, I'm most of the time not going to use that dreadful word. But I understand that you guys generally, like, you get it, you know what you're doing. So when I describe it, I'm going to say down to right 3. And again, the word over can mean 2 different things, which is why I care. Because had Brendan gone over to the left 3, then his entire problem is blown, right? And you can do that as many times as you'd like. I know that on Delta Math, you only have to do it once, but like when we're doing it on paper, what I find is it's usually a good idea to kind of milk the graph paper for all it's worth. And so instead of going down 2 and left 3, you see that by going up and left, I'm creating the same relative tilt. At the end of the day, man, I got a line that goes downhill and it's got a ratio of 2 to 3, 2 rises for every run. And that's how easy it is to graph a line. When we graph lines on paper, again, Delta Math will do this for you, but when we graph lines on paper, we want our line to extend out both ends of the grid. All right, no little baby sticks. And then on the ends, of course, you know that we have to put arrows. Otherwise, it doesn't go on forever. Any questions on that? We'll practice. I mean, don't worry, that's not like the extent of it. Like, hey, good luck, suckers, go. But I mean, that's the gist of it is that's how you graph a line when it's given to you in slope intercept. How about this one? Where do we start?
You go down five.
Thank you. Down five is exactly the word I want to hear, right? Down five. And it's not like I have an issue with, you know, words in general. I just, when people say -5, I have graded a lot of papers where people think, oh, I start the graph at -5 and they go over here. And it's like, oh, no. So we want to be real tight. We're going to go down five. 1, 2, 3, 4, 5. And we're going to plink our home base right there. What is the slope of this line?
Go over to the right.
You don't. The slope is not a fraction, and I know that I'm always telling you to simplify everything, but in a case like this, just for your educational like benefit, it's a good idea to actually unsimplify 3 and think of it as 3/1. And then you can actually see the slope, right? Up 3, right 1. So from that home base, we're going to go up 3, 1, 2, 3, right 1, up 3, right 1. And we're just going to track that a bunch of times. And then we would put a line on there. So the purpose of that example is that when your slope is a whole number, you don't have to write it as a fraction. Just always bear in mind, though, that it is. And so then you've got your rise and your run, at least in your brain or on your paper or both. Okay. How about this one?
Would that be
It's
down?
first off, is it in y equals mx plus b? It is. You just don't see that at the end of it, there's a little zero. And if you really wanted to put it, you could. Just FYI.
Would it be down one to the right one?
First, I want to talk about the answer to the question that comes before that, and then we'll get to that, okay? Where do I start my graph? Right at the origin, at 0. We don't go up, we don't go down. And so I can plink a point right there at 0, 0. Now, Cal, what were you saying about the slope?
Go down one, over one.
Yeah, and again, I'm going to try to get over you guys saying the word over, but
Over to the right.
good. And so the slope, you can't see it, but there is, of course, a number there. We've been talking about this all year, that when you can't see numbers, they're there, right? They're just ones. So in this case, it's a -1, which if we write it as a fraction is -1/1. And Cal said it pretty well that that is just a down one, right one, down one, right one. And if you want to save time, like if we were doing this on paper, you could go like down 5 and right 5, and you can save a bunch of time that way. You're still getting the same down one, right one ratio. You're just chunking out bigger stretches of real estate. Do you guys have any questions on that just general idea? Okay, the other thing for today is that I want to talk about some very particular special types of lines, and they are vertical and horizontal lines.
But no slope and zero.
Correct. And I can say I have a benefit, you have a benefit of having an older teacher who's done this a lot. And I can just tell you this, you can take this or you can leave this. This is a hot spot for mistakes. And I'll explain to you exactly why people screw this up. I'll explain to you how to do it, and then I'll give you the perspective, and you should kind of go, yeah, I can see how that's an easy mistake to make. So first off, with a vertical line, you're always going to have an equation that's in this format, x equals a number. X equals 4, x equals -1, x equals 0, x equals 3/2, x equals something. When it's written like that, it's vertical. So like, for example, if I gave you an equation like x equals 4, this is how easy it is to do. You go to the right 4, 1, 2, 3, 4, and you make a little mark, and then you go grab your ruler and you draw a vertical line like this. Can you guys, I mean, can you kind of beat me to the punch? Can you think, sitting here right now, you're thinking like, how is that hard? Like why would people mess this up?
Oh, they must be perpendicular.
Because the x-axis goes sideways. And you have a choice to make. Like, do I want to keep listening to this man and trust him, or do I want to say, no, he's just droning on? You should trust me. People think that because x is sideways, which it is, by the way, when we graph, like x is our sideways number, right? But when you have an x equals line, the line actually goes vertical. And let's think about why that is. I'm going to put purple dots on my line. Actually, I'm going to use green, and I want you to tell me what the x coordinate of the point is that I blotch. Are you ready? Go. What's his x?
4.
Okay, good. How about this one?
4.
Okay, I'm going to trick you with this one. How about this one?
4.
Hold on. So they all have what? For their, I mean, that's why vertical lines are x equals, because every point on the line has the same x coordinate. That's the only rule you have to follow to be in the vertical club, is you got to have the same x coordinate, right? I could keep doing that. I could go, oh, look, x equals 4, x equals 4. I don't care what the y coordinate is, but if your x is 4, you're on that red line. What do you guys think the equation format is for a horizontal line?
Y equals?
Very much so, yes. So if I did y equals a number, like let's do -3, we'd go down 3, make a mark, and then we reach over and we grab our ruler and we draw a horizontal line that goes through a y coordinate of -3. And I'll ask you the same question, but you don't have to answer it because it's almost rhetorical. But can you see why people get these backwards? Which way does the y-axis go? This way, right? But then y equals lines go the dead opposite way. And the explanation is to, if someone were to go, well, why is that? Well, I'll give you the same explanation again. What is the y coordinate of that white point? How about this one? How about this one? How about this one? How about this one? To be on that line, you have one rule you got to follow, and that is that your y quite literally has to equal -3. So you've been warned. Verticals, x equals, horizontals, or y equals. All right, so now I'm going to get in here and show you what the delta math looks like, and then I'm going to get out of your way. So no Chromebooks or anything yet. Just hang tight. Let's see. There's a way for me to do this. Let's see. Sample student page from this class. Why is this thing in my way? There we go. Next section. All right. Help me graph this line. Can you guys see it?
What's that +5?
Don't say that, please. Start at what? Start at up 5. And again, I'm not here to pick fights with you, but if I had $1 for every time some knucklehead started at the wrong -5, I could probably pay off half my house. So we're going to start by going up 5. And from there, what's our slope?
You go down 3.
Down 3, right 4. Right 4. Good. So down 3, 1, 2, 3, right 1, 2, 3, 4. And that's how easy it is to graph. It gives you the line, which is super, super sweet. Okay, let's go to the next one. How about this one? Where would I start my graph?
0.
At down 2, because there's a -2 at the back. So we're going to start by going down 2. And we saw this in our notes. What's the slope?
Go down 1 to the right.
Down 1, right 1, and you only have to click it once and it makes the line for you. Got it? Next one. How about this one? Start by going down 2. What is the slope?
Down 2.
What is the slope? Say it to me as a number. What is the slope? It's 2. It's 2. And is 2 a positive number or a negative number? Then I don't care what else happens, but if your line comes out looking like this, then you and I are going to have a talk about your understanding of slope, right? So you do whatever you have to do, but at the end of the day, you know the slope's +2, you dang well better make the line go uphill. So now you give me some up, down, right, lefty words.
Up to left.
Up 2, right 1 is perfect because the slope is 2/1. So up 2, right 1, up 2, right 1. Boom, there's your slope of 2, just like that. Now let's go again. How about this one? It says to graph the line x equals -4. The first thing you'll have to do on these problems is choose. Does this say horizontal or vertical line? You want to say horizontal so badly because you're human and the x-axis goes sideways and you're like, sideways is called horizontal. But as we discussed, this is a vertical. It is backwards for a reason. Now it says just to drag the line, grab the yellow dot and grab it. And I'm going to hitch it right here at -4. And that's all you got to do for those. Thought it would be a good warm up to get this done on Delta Math first. And then we'll do some paper ones starting tomorrow. What kind of line is y equals 1? So I'm going to choose horizontal and then it's going to give me a horizontal. And where am I going to hitch it? Right at 1. Y equals 1 is right there. Okay. Next one. How do I graph x equals 6? What kind of line is it?
Vertical.
It's a vertical. So I'm going to grab the yellow dot, go to x equals 6, boom. And it snaps. So if you just get closer to it than any other number, the program will pull it into place. So you don't have to sit there and stare at it for like a minute. All right. How about this? This asks us, hey, here's a line, write the equation. First off, what's the equation going to start by saying?
X.
X equals
7.
something. Good job, Justice. I can see that it hitches right through 7. So I just go into the box and I type in x equals 7. And that's all there is to that. How about this one? What is the equation of this line?
Y equals 1.
Y equals 5. It goes through, but you can see the 4 and the 6. So we, of course, know it's 5. So Y equals 5. All right, and I got just a few more. Y equals 5. It says to graph it. What kind of line is y equals 5? Horizontal, and we're just going to drag it down to 5. And again, look, if you just get kind of close like that, you just let go, it snaps it. It'll snap to whatever's closest. All right, this is the last section, and then I'm out of your way. This time it says to graph the line and then name the equation. So the first thing we're going to do is we got to know how to plot points. Could you guys guide me? I'm not very good at this graphing point stuff. How do I get to the point 0, -6?
You go down 6 from the board.
That's all you do is you go down 6 and click a dot. Boom. The other point up there in the corner you see is -6, -1. How do I get there?
Left 6, down 1.
Perfectly spoken. And then look at this. You click the points and Delta makes a graph. Boom. And then all you got to do is write the equation. So based on what you learned about 10 or 15 minutes ago about y equals mx plus b, what would you say is the equation of this line? This is like the final boss battle. If you can answer this question, good job. What is the equation of that line? I'll get you started. Y equals. What's the slope?
1. Down.
I believe the slope is -1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6. So I'm going to put -5/6 of x. And where does this graph cross through the y-intercept, the y-axis?
-6.
Therefore, I will finish off my equation with a -6. A little bit of an extra challenge there, right? So rather than me giving you the equation and you graphing the line, we give you the line, you write the equation. So we just go down into the little box and we type it in. So we just type in y equals -5 divided by 6. Make sure when you're done, do you see how my cursor's down in the 6? Hit the right arrow and it jumps back out. And then you can do your x minus 6, I think we said. So you're making the line from the points, and then you have to name the equation of the line. Help me try this one. There are the points. How do I get to 3, 2?
3, right, down 3.
Uh,
Up 2.
right 3 up 2. Click. How do I get to 6, 7?
To the right 6, up 7.
Up 7. Boom. And again, the line pops up, and now I just have to be able to eyeball 2 things about it. First off, I know it's hard to see, but whatever. What's the slope of that line? Let's see if we can find some. What did you say it is?
4.
Let's see. Let's go from point to point and see how you did. Up 1, 2, 3, 4, 5. 1, 2, 3. So the slope is 5/3. What does that mean my equation is going to start with? Y equals what?
5/3.
5/3 x. And then the last part of it is just the easy one. Where does it hit the y-axis? At right there. The y-axis is down 3. So I will finish my equation with a -3. Got it? So y equals 5/3 of x minus 3. And then I think I've only got one more on here. I tried to pick ones that each had a purpose. So how about this one? Stay with me.
To the left, 4, down 9.
Left 4, down 9. Click. Where's the other point?
To the left, 4, down 8.
Click. What kind of line is this? Vertical. How do we write the equation of a vertical line? That's not this. I didn't ask for the slope. X equals -4. We learned today that vertical lines are always x equals where they are. And this line is at -4. So it's x equals -4. Good job there, Justice. X equals. No one asked us for the slope in that case, just the equation of the line. And I think I probably have one more, I'm guessing. So maybe 2. How do I get to -8/6?
Left,
Left
8,
eight.
up 6.
Boom, go clicky click. How do I get to -6/3?
Left 6, up 3.
Clicky click. And again, everything I need is right in front of me. So the first thing I need is the slope, because when I start writing my equation, I go like this, y equals, and I get stuck. So what is the slope of that line? Stop saying over. Down 3, right 2. The slope is -3/2, correct? -3/2. And then on that, I stick my x.
-4.
And then where does it stop looking at the x-axis? Where does it cross the y-axis? At down 6, -6. So we end the equation with a -6. This point right here is of no significance yet. It will be someday very significant. Oh. Y equals -3/2 of x minus 6. And I had one more, I'm sure of it. Last one. It's got to be. Yeah, this is my last guy here. And even if it's not, we're done, because this is the last thing I wanted you to see. How do I get to the point 8, -3?
Right 8.
Right 8, down 3. Perfectly spoken. How do I get to the point 2, -3?
2.
Kind of line is this?
Horizontal.
Horizontal. So again, when we say what's the equation, we don't want to say 0. We don't want to say no slope. We want to say, what is the equation of the line? Yeah, good job. Thank you. It is y equals -3, because it's a horizontal line, and that's what we now know, is that horizontals are y equals where they're at. You guys good? All right, so your assignment's on the old delta. Look at that. I completed the assignment. Woo! I'll keep my recording alive but paused.